Welcome to Click Academic. This is lesson 4 on the series Mathematical Method. We will be solving another example on mean value theory. This example said, prove that the function defined by f of x is equal to x plus 4 divided by x satisfies the hypothesis of mean value theorem on the interval, open interval 1, 4. Close interval 1, 4. And find the number c in the interval, that is open interval 1, 4, which satisfies the conclusion of the theorem. Solution. We are given the function f of x is equal to x plus 4 divided by x on the interval 1, 4. So to prove that this function satisfies the hypothesis of mean value theorem, we are to find the function of 1 and 4, which is our a and b, to see whether the function is continuous on this point. So this 1 is our a and b is our 1 is our a, 4 is our b. So f of a is equal to f of 1 because our a is 1. So anywhere we have x, we should now replace 1. We have x plus 4 divided by x, and our x is 1. This is equal to 1 plus 4 divided by 1, 4, which is equal to 5. Then f of b is equal to f of, our b here is 4. So anywhere we have x in the function, now we replace 4. X, our x is 4 plus 4 divided by x, and our x is 4. This is equal to 4 plus 4 divided by 4, 1. 4 plus 1, 5. So now we find f of a and f of b. F of a is equal to 5 and f of b is equal to 5. The function is continuous on this point because they are all not divided by 0. Then the second condition says the function must be differentiable. So let's see, can we differentiate the function? We are given the function f of x is equal to x plus 4 divided by x. So to differentiate this function, we should now take this x top. We should now take this x. The x here is at the denominator, so we should now take it to the numerator in order to differentiate the function, to avoid using quotient rule. Therefore, we are given f of x is equal to x plus, so taking x up there, it will be x raised to power minus 1. Therefore, to differentiate this function, derivative of the function is f prime of x, which is equal to derivative of x, 1. Derivative of 4x raised to power minus 1. Remember, to differentiate the function, power multiplied by the coefficient, then reduce 1 from the power. So minus 1 times 4 is minus 4. Then x. Reduce 1 from the power, that is minus 1. So minus 1 minus 1, minus 2. This is the derivative of the function. Yes, the function is differentiable because we differentiate the function and we still have a variable in the function. Therefore, the function is continuous on the interval. Remember, as we said, continuous on the closed interval 1, 4, and differentiable on the, remember, on differentiable we say close, so 1, 4. Then since the function is continuous and differentiable, therefore the function satisfies the hypothesis of mean value theorem. So if the function satisfies, we say then f, we know that f prime of c is equal to f of b minus f of a divided by b minus a. F prime of c is equal to f of b minus f of a divided by b minus a. The conclusion, or the last part of the question, say we are to find the number c in the open interval 1, 4. So as you say, to find that number that exists between the open interval, you are to use the conclusion of the theorem, and this is the conclusion of the theorem. F prime of c is equal to this. So, but we don't have f prime of c. Since we have f prime of x, we can find f prime of c. So our f prime of c is equal to, anywhere we have x in this function, we should now replace it with c. So we have 1 minus 4x. We say that we should replace c instead of x. So 4c raised to the power minus 2. This is our f prime of c. Then the conclusion of the theorem said f prime of c is equal to this. So our f prime of c now is equal to 1 minus 4c raised to the power minus 2, which is equal to f of b. F of b is 5 minus f of a. F of a is 5 divided by b, and our b is 4 minus a. A is 1. So 1 minus 4c raised to the power minus 2 is equal to 5 minus 5, 0, divided by 4 minus 1, 3. 1 minus 4c raised to the power minus 2 is equal to 0, because 0 divided by 3 is 0. We are looking for c. So now, if you like, from this step, you can remove this negative from the power. And we know that when we are to remove the negative from the power, the term that contains that negative power will go down. So 1 minus, since 4, this negative 2 doesn't affect 4, so 4 still remain at the top. Then divide by c squared is equal to 0. Then since we are looking for c, and the term that contains c is negative sign, you can take it to the other side in order to become positive. So 1 is equal to 1 minus the whole this cross the equal sign become positive. 4 divided by c squared. We are looking for c, so we have one term at the left hand side and one term at the right hand side. So you can now cross multiply. The same thing as divided by 1 here. If you cross multiply, 1 times c squared is c squared, then it's equal to 1 times 4, 4. We are looking for c, not c squared. So you should now take this square to the other side. C is equal to, if squared across equal sign become square root. And as we said, if we have square root, it's either plus or minus. Then square root of 4. C is equal to plus or minus. Square root of 4 is 2. So our c is equal to plus 2 or minus 2. But if we look at the interval giving us 1, 4. And remember that c exists between the open interval, not closed interval. So the numbers between 1 and 4, we don't have minus 2. Minus 2 doesn't exist between 1 and 4. But if you look at the numbers between 1 and 4 are 2, 3 only. So plus 2 exists between that interval. So our c is equal to positive 2. That's all.